All right, for this simulation, we are going to be looking at two different circumstances. So we're going to start with this Lycoming engine. The O300 engine is 250 pounds, and it's going to be attached at 3 points. So we have these three attachment points that we're connecting this engine to. That means that if the airplane is just sitting on the ground, then you take the 250 pounds, divide it by the number of mounting plates that it's attached to. So there's three. So you take 250 divided by 3, and you get 83 to 84 pounds at each connection. And this is a simplification of this process, but that's how we're going to work with this. So what that means is when the engine is just connected, each one of these plates is holding up about 84 pounds. All right, let's think about the negative 3G and the positive 6G climbs or dives. And what we're going to simulate here is if it's in an aggressive climb or in an aggressive dive, how much forces, what kind of force, how's the force distributed? That's what we need to understand. Okay, so for the positive 6G condition, that means that we have the mounting plates here. The engine is connected to these 3 points, and we are going to take, since it's 6G is 6 times the force of gravity, and so we're going to start with 250 pounds times 6. That gives us 1,500 pounds for the engine itself, but it's connected to the 3 plates, so you take 1,500, divide that by 3, and that puts 500 pounds on each plate. And in this case, it's a positive 6G, so it's the same direction as gravity. And that means the force is going to pull downward, so the arrows would point down. So you would label each one of these with 500 pounds, and the force is going down, just like the weight. Okay? Now let's think about the negative 3G dive. So in this case, the airplane is diving, and the force generated by the dive is greater than that of gravity. Okay, so what we're going to do is at negative 3Gs, that means it's 3 times the force or the weight that you would normally see. So 250 pounds times 3 gives us a total of 750 pounds for the engine, but it's mounted on the 3 plates, so 750 divided by 3 is 250 pounds on each plate. And since this is in a dive, the weight is actually pushing upward in relation to the frame, so you would have 250 pounds pushing up. Okay? That should help you with the calculations and showing your work. Thank you very much.